Hello, my name is Sawyer West, and today we will be considering how to optimize your code with check domains. So what is the check domain? You receive an input, you want to run some checks on that input to determine some output, and the check domain is the set of checks you're going to be using. Now, what is our current check domain? Well, it's the natural numbers greater than 1. So it's 2, 3, 4, 5, 6, 7, 8, 9, so on and so forth. But can we do better? Yes. Any composite number, which is a number which is representable as the product of primes, is unnecessary. Why, you might ask? Well, if a number is, let's say it's divisible by 4, it's always going to be divisible by 2, because 2 times 2 is 4. And if a number is divisible by 6, then it's always going to be divisible by 3, because 2 times 3 is 6. And in general, if you have a composite number, C, and that divides your candidate X, then X is always going to be divisible by any of the primes that compose C. So what might this look like in code? Well, we pass in our vector of primes, and we iterate through the vector of primes, and we check if our candidate is divisible by any of those. But you might notice something a little odd. The amount of speed up we've gotten from this doesn't look very impressive. You see, in this last slide, we had about 12.6 milliseconds, and we're doing a lot less checks here, and we're only getting 10.4 milliseconds. What could be going wrong? Consider this. We are passing in a vector of integers now, which could get considerably large, because when we ran this test, we were trying to find the first 1,000 prime numbers. And we are copying and pasting all that data over and over and over again into this isPrime function. And that could have some considerable overhead. What would be much faster if we could tell our program just to say, look in that location in memory, just consider what's in there. Don't copy and paste it over, just consider what's there. Use that. And how we can do that is we can put a little ampersand symbol right here. This is a pass-by reference. And as you can see down here, that has sped up our program considerably. We went from 10.4 milliseconds to 1.6 milliseconds. That is blazingly fast compared to what we had before. Thank you for watching. Like, subscribe, hit that bell.